For decades, one company defined modern computing. If you bought a computer in the 1990s, the 2000s, or even the early 2010s, there was a good chance it had one name stamped inside it: Intel. Intel Inside wasn't just marketing, it was dominance. Intel didn't just power computers, it powered entire industries. Its x86 architecture became the global standard. Software, operating systems, enterprise networks, all revolved around Intel's designs. Businesses relied on it, governments relied on it, and for decades Intel set the rules of computing. Founded in 1968 by Robert Noyce and Gordon Moore, Intel rose from a small semiconductor startup to a global powerhouse. Noyce, the co-inventor of the integrated circuit, and Moore, famous for Moore's law, envisioned a world where computing power doubled every 2 years. Intel delivered on that promise, turning itself into the undisputed king of the PC era. Its IPO in 1971 made waves in the tech world, and the company's reputation became synonymous with progress, reliability, and performance. But technology doesn't reward comfort. Revolutions rarely announce themselves loudly. Sometimes they start quietly inside your pocket. While Intel focused on high-performance chips for desktops and servers, a small British company was designing something different: efficiency. That company was ARM, founded in 1990 by Herman Hauser and Sophie Wilson. Unlike Intel, ARM didn't manufacture chips. It created blueprints, flexible, energy-efficient designs that could be licensed to other companies. At first, these designs seemed niche, irrelevant to the powerful desktops that Intel dominated. But when smartphones exploded, everything changed. ARM's architecture became the foundation for mobile computing. Its chips were used in Apple's iPhones, Qualcomm's Snapdragon processors, Samsung devices, and countless other products. The advantage was clear: devices could be lighter, last longer on battery, and still perform at a high level. Billions of devices worldwide now ran on ARM-based designs. Meanwhile, Intel struggled to enter the mobile market. Its attempts with Atom processors and Medfield chips failed to gain traction. While Intel maintained its PC and server dominance, ARM quietly became indispensable. ARM's strategy wasn't to beat Intel at its own game. It changed the rules entirely. And in doing so, it set the stage for the next era of computing. Intel's history in mobile computing reads like a series of near misses. Early attempts, like the Medfield and Atom series, promised low-power mobile solutions but were consistently outperformed by ARM-based competitors. Apple's decision to build its own M1 and M2 chips on ARM architecture was a watershed moment. Not only did it deliver performance comparable to Intel laptops, but it did so while consuming far less power, redefining efficiency standards. Financially, the cost of Intel missing mobile is staggering. While Intel's PC revenues remained strong, mobile devices and tablets became the dominant consumer platforms. Competitors licensing ARM architecture captured market share that Intel had assumed it could eventually take. Analysts repeatedly warned investors Intel risked becoming a legacy PC chipmaker, while ARM seized the future. Intel's failure wasn't due to a lack of innovation, but a combination of bureaucracy, focus on desktop dominance, and manufacturing complexity. ARM's flexibility allowed it to thrive without the overhead of owning fabs. The old king was still powerful, but the playing field had shifted. The next battlefront emerged in the cloud. Data centers consume massive amounts of electricity. Even small efficiency gains can save millions of dollars annually. For cloud providers like Amazon, Google, and Microsoft, this is critical. Enter ARM's architecture, which delivers comparable performance at a fraction of the power consumption of Intel's x86 chips. ARM began infiltrating server farms through custom designs like AWS's Graviton processors, optimized for efficiency and cost-effectiveness. AI workloads further emphasized flexibility. Training complex machine learning models requires specialized hardware, memory bandwidth, and energy efficiency. GPUs have been dominant in AI, but ARM-based CPUs and specialized accelerators are emerging as vital alternatives. offering the balance of performance and efficiency required for the next generation of AI applications. Intel, while still dominant in many traditional data centers, found itself reacting. ARM had set the pace, and the rules of computing were being rewritten. Intel's historic strength lay in vertical integration. Designing chips and producing them in its own fabs gave Intel unparalleled control. But as semiconductor nodes shrank into nanometer precision, Intel encountered unprecedented challenges. Delays in 10nm and 7nm production slowed their roadmap and gave ARM licensees access to advanced foundries like TSMC, which could produce chips faster and more efficiently. The geopolitical landscape added complexity. The US government launched the CHIPS Act to encourage domestic semiconductor manufacturing, while Taiwan became central to global chip supply. Intel invested billions to expand its foundry capabilities, aiming to manufacture not just for itself but for other companies. ARM, meanwhile, continued licensing globally, sidestepping the manufacturing burden entirely. One designs, one builds, both are powerful, but the rules have changed. Intel's challenge now is not just competition. It's staying relevant in a world where innovation is measured in efficiency, flexibility, and speed to market. The battle isn't theoretical, it's visible in products. Apple's MacBooks now use M1 and M2 ARM-based chips that outperform many Intel laptops in speed, graphics, and battery life. AWS's Graviton processors dominate cost-sensitive cloud instances, providing scalable and energy-efficient solutions. Intel's Core i9, Xeon, and other processors still deliver raw performance, but they face a new standard of efficiency that ARM set. AI is the next frontier. Intel's investments in AI accelerators, Nvidia's chips, and Nirvana technology aim to compete with ARM-based AI-optimized designs. Nvidia, a heavy user of ARM architecture for mobile and edge AI devices, adds pressure and highlights the ecosystem shift. The battlefield is no longer just desktops, it is laptops, servers, edge devices, and AI accelerators. Intel's traditional customers remain loyal, but younger innovators, startups, and cloud-first companies increasingly prefer ARM's scalable and adaptable architecture. Intel's stock has fluctuated as its market share challenges grew. From the late 2010s into the early 2020s, investors questioned whether Intel could keep up with a fast-moving industry. ARM, after its IPO via SoftBank, commanded enormous valuations, with its market capitalization reflecting its licensing dominance and global reach. Meanwhile, TSMC's growth skyrocketed as ARM's licensees relied on its foundries. Nvidia and Apple further boosted investor attention toward ARM's ecosystem. Global chip shortages during the pandemic highlighted the fragility of Intel's supply chain, creating additional pressure. Financially, Intel remains profitable, but growth is slowing. ARM's value lies in ubiquity and licensing, a model resistant to direct competition and operational bottlenecks. Intel has scale, decades of engineering talent, government support, and enterprise relationships. ARM has momentum, efficiency, flexibility, and nearly ubiquitous adoption in mobile and edge computing. Nvidia, Apple, Qualcomm, AWS all contribute to ARM's ecosystem, reinforcing its strength. The question isn't whether Intel disappears. The question is whether it can reinvent itself fast enough to compete in AI, cloud, and next-generation devices. In technology, dominance is temporary. Intel built the PC era. ARM built the mobile era. The AI era will decide who defines the next chapter of computing. And this time, there is no default. There is no king. The landscape belongs to those who can adapt. This is the chip war that will shape the next decade. Every design choice, every foundry decision, every AI chip could tip the balance. Will Intel reclaim dominance? Will ARM continue its rise? Or will a new challenger enter the stage? Subscribe to Stag Research for deep dives into the companies defining the future of technology.